So let's look at another rule, which is the quotient rule. So notice that the function fx is a ratio of two functions. So you got function 1 marked in green, function 2 marked in yellow. So y is a ratio of fx to gx. So it's a ratio, it's no longer a product. So we apply the quotient rule. Now when you're applying the quotient rule to obtain dy dx, we start with the denominator. It's gx times the derivative of fx. Here it is, gx times the derivative of fx minus fx times the derivative of gx. So here it is, fx times the derivative of gx divided by gx squared. Gx is the term in the denominator, gx squared. So let's look at the example. Here we have y expressed as a ratio of two functions. So we take here, okay, let's mark the two functions. Here is function 1 marked in green, function 2 marked in yellow. So we want to apply the quotient rule to find the derivative of y with respect to x. So it's the function in the denominator, x squared plus x, times the derivative of the function in the numerator. So derivative of the function in the numerator, 6x cubed, derivative of that is 18x squared, derivative of 5x is 5, minus the function in the numerator, which is 6x cubed plus 5x, times the derivative of the function in the denominator. So derivative of x squared is 2x plus derivative of x is 1, whole thing divided by the function in the denominator, all squared. We can simplify the expression by expanding the numerator and grouping the like terms, which is left as an exercise for you to complete. Let's look at another example, example 15. Y is a ratio of two functions. There is one function in the numerator which is colored yellow. There is a second function in the denominator which is colored green. So y is a ratio of two functions, and to find the derivative of y with respect to x, we could apply the quotient rule. Now before we apply the quotient rule, we could write y in a more convenient form. Notice that in the numerator there is this term 2 on x, which we can write it in a more convenient form. So let's write y in a more convenient form. The numerator can be written as x plus 2 on x can be written as 2x raised to the power minus 1, and the denominator can be, let's rewrite the denominator. Now that we've written y in a more convenient form, we can apply the quotient rule. So we will take the denominator, multiply that with the derivative of the numerator. Derivative of x is 1, derivative of 2x raised to the power minus 1 is 2x raised to the power minus 2, minus the numerator times the derivative of the denominator. So derivative of derivative of x cubed is 3x squared, and derivative of x raised to the power 4 is 4x cubed, and the whole thing divided by the denominator squared. We can now simplify the numerator by expanding out the brackets. We'll expand these two brackets first, followed by we'll expand these two brackets afterwards, and then we can group the like terms to simplify the numerator. So let's do that. So if we multiply x cubed by 1, we'll get x cubed. X cubed by minus 2, x raised to the power minus 2 will give us minus 2x. X raised to the power 4 multiplied by 1 will give us x to the 4. X to the 4 multiplied by minus 2 x raised to the power minus 2 will give us minus 2 x squared. Minus, we'll expand these two brackets. So x multiplied by 3x squared will give us 3x cubed. X multiplied by 4x cubed will give us plus 4x raised to the power 4. 2x raised to the power minus 1 multiplied by 3x squared will give us 6x. 2x raised to the power minus 1 multiplied by 4x cubed will give us plus 8x squared. And we can rewrite the denominator. X cubed plus x raised to the power 4 all squared. We can now group the like terms in the numerator. So we have x raised to the power 4 minus 4x raised to the power 4, which will give us minus 3x raised to the power 4. We have x cubed minus 3x cubed, which will give us minus 2x raised to the power 3. We have minus 2x squared minus 8x squared will give us minus 10x squared. We have minus 2x minus 6x will give us minus 8x. So that's the numerator, and we can rewrite the denominator. X cubed plus x to the 4 all squared. So that is the derivative of y with respect to x.